All right, let's dive in. We're about to pull back the curtain on one of the most fundamental ideas in all of math. Seriously, this is kind of like the secret language that powers, well, everything else.
So let's kick things off with a pretty big question. What if math isn't just a subject you take in school? What if it's actually a language? I mean, a language specifically designed to describe the world around us with like perfect, laser-like precision.
Okay, so if we're running with this idea that math is a language, then set theory, that's its alphabet. It's the absolute basics. And the very first letter we have to learn, the A of this alphabet, is the concept of a set. Now, the official definition sounds super simple, right? A collection of well-defined things or objects. Easy. But don't let that fool you. The entire secret, the magic sauce, is hiding in those two little words, well-defined. Seriously, getting this next part is the key to the whole shebang. So let's really dig in and figure out what well-defined actually means. A few quick examples should clear it right up.
All right, check this out. On one side, we have a collection of good movies. Now, if I ask you for your list of good movies and then ask someone else, we're going to get totally different answers, right? That's because good is an opinion. It's subjective. But on the other side, novels by Munshi Premchand. There's no debate there. A book either is or it isn't written by him. It's a fact.
Okay, same deal here. Dangerous animals. A spider might be terrifying to you, but it's a pet to someone else. A big dog could be dangerous or a good boy. It totally depends on who you ask. But people in this room wearing glasses? That's a straight up yes or no question. We can look around and agree. The answer is the same for everyone. See the difference? That's what well-defined is all about.
So here's the bottom line, the absolute key. The absolute key, a collection is well-defined if and only if, for any object in the universe, the question, does this belong in the group, has the exact same yes or no answer for everybody. No opinions, no debates, just a cold, hard fact.
Okay, awesome. So we've got it. A set is a group where everyone agrees on who's in and who's out. But now, how do we actually, write this stuff down? In the language of math, there are two main ways to do it. I like to call them the direct attack and the indirect attack. The first one is super straightforward. You just list everything out. The second one is a little more clever. It's about describing a unique quality that only the members of the set have. Think about it like this. The direct attack, that's like calling someone out by name. Shantanu, please stand up. There's no confusion. The indirect attack is more like describing a unique feature. The person in the yellow shirt, please stand up. Now, if there's only one person wearing a yellow shirt, you've identified the exact same person, right? You just did it in a different way. So that direct attack has an official name, roster form. And it's really simple. You use these curly brackets, and you just list out every single member, separated by commas. But you've got to remember two super important rules. First, the order you write them in doesn't matter at all. The set 1, 2 is the exact same as 2, 1. Second, you are never allowed to repeat an element. So 1, 1, 2 is just 1, 2. Repetitions don't count. All right, now for the indirect attack, which is officially called set builder form. I know. At first glance, this can look like some kind of complex computer code. But trust me, it's not. It's just a really, really precise sentence that lays out the rules for who gets into the club. Okay, so remember that set from before, A equals 1, 2, 3, 4, 5? Well, in set builder form, it looks like this. Yeah, I see it, but don't panic. We're going to break this down symbol by symbol. It's easier than it looks. First up, that colon, the two dots. Anytime you see that symbol in set theory, I just want you to say the words such that in your head. That's all it means. It's just the divider between our variable x and the rules that x has to play by. Next, we've got this little symbol here, the one that kind of looks like a curvy E. This one simply means belongs to or is an element of. It's just telling us what big group our x is a part of. And last but not least, that capital N. This is a famous one. It's just shorthand for the set of all natural numbers. You know, the numbers you first learned to count with as a kid. 1, 2, 3, 4, and on forever. Okay, so let's put all the pieces together and just read this thing like a sentence. It says the set of all elements x such that x belongs to the natural numbers and x is less than or equal to 5. And what are the natural numbers less than or equal to 5? Well, they're 1, 2, 3, 4, and 5. It's the exact same set, see? It's not scary code, it's just a super precise language. All right, before we finish up, I want to hit one last really important idea, and this is one that trips a lot of people up. It's the difference between a set that has nothing inside it and a set that has the number 0 inside it. They are not the same thing. So look here. On the left, we have the empty set, or the null set. The best way to think of this is as an empty box. There is literally nothing inside. It contains 0 things. On the right, though, we have a singleton set. This is also a box, but this box isn't empty. It has exactly one thing inside it. And what is that one thing? It's the number 0. These are two completely different ideas. And this, right here, perfectly illustrates the whole point of this mathematical language. You know, in our normal everyday thinking, we kind of mush together the ideas of 0 and nothing. But in the super precise world of set theory, the number 0 is an actual thing. It's a distinct element. It is a something, not the absence of everything. So there you have it. You've just learned the absolute foundational alphabet of modern math. And really, this isn't about, just passing a test or something. It's about getting a peek into a whole new language for describing the world with incredible clarity. So the real question isn't what you've learned. It's what are you going to build with it?